Hello all, my name is Hemant and in this video we are going to discuss mathematics questions from part test 7. So let's get started. Question number 51 is the degree of the differential equation of all tangents to the parabola y square is equal to 4ax is. So on this parabola any tangent can be written as, any tangent equation can be written as y is equal to mx plus a by m. This is the standard thing that you need to remember, where m is a parameter basically. Now to form the differential equation and then only we can know about the degree, what we need to do is differentiate with respect to x. So we'll get dy by dx, that is equal to m, and this a by m, since a is a constant, m is another parameter, again the differentiation is 0. So I can plug in this value of dy by dx in the first equation where we have written the equation of tangent. So it will become y is equal to dy by dx times x plus a divided by dy by dx. Now let us multiply by dy by dx throughout. So this will be y dy by dx, and here we will be getting x times dy by dx whole square plus a. So clearly it is visible that highest order derivative is dy by dx, which is 1, and the power or the highest power on the highest order derivative is 2. So clearly degree will be 2. Option number B is the right answer. Question number 52 is the area of the region bounded by parabola y square equal to 4ax and its latus rectum is. So first of all, let's draw a standard parabola of y square equal to 4ax. So its diagram will be something like this. It will be symmetric about x-axis, and this is the focus represented by s. Its coordinate is given by a comma 0 for this type of parabola y square equal to 4ax. Now they said the area of the region bounded by this parabola and its latus rectum. What is latus rectum? It is the line basically which is passing from the focus perpendicular to the axis, and the extremes lie on the parabola itself. It means this is the area. If I give some names, OA, B, and again back to O. So this entire area we have to find out. So since this is symmetric about x-axis, even if we find out the area of this top portion A1, then the downward portion, this will be exactly same as A1. So required area A will be equal to 2 times of A1. Now how to find the area of this particular portion? We can take a vertical strip. Okay, we can take a vertical strip and we can integrate from 0 to uh, a. Okay, so this will be 2 times 0 to a y dx. This small strip area is y dx. Okay, this is the height y and this is the small width dx. So once we start to integrate, we'll get to know that this is 2 times of 0 to a. In place of y, I can write 2 root of a root of x dx. So overall it will become 4 times of root a. Root x integration will be x power 3 by 2 divided by 3 by 2. We'll put the limits also 0 to a. Till then this 3 by 2 uh, along with this 4 will give us 8 by 3 root a, and once we put the limits we'll get a power 3 by 2 minus 0. So if we multiply this root a with a power 3 by 2, we'll get 8 by 3 a square units, which is option number C. Question number 53 is the differential equation obtained by eliminating k from y is equal to x plus k into e power minus x is. So since we have to eliminate the parameter k, we can write this as x plus k e power minus x. Let's multiply with e power x both sides. So this will become y e power x equal to x plus k. Okay, this e power minus x is cancelled with e power x, basically they will nullify each other. So now we can differentiate both sides. So differentiation of the entire thing with respect to x, if we do, what we'll obtain, we'll be getting y e power x differentiation is e power x plus, this time we can say e power x as it is, it remains, and the differentiation of y will be dy by dx. Right side will be getting as 1. So finally I can say that this is y plus dy by dx. E power x is taken as common. that is equal to 1, and therefore y plus dy by dx is equal to 1 by e power x, which is e power minus x. So correct option is D. Question number 54 is the area of the region bounded by the curve y square equal to 4ax, x equal to 1 and x equal to 4. So again, this is a very simple question, standard area related questions. You just draw this parabola y square is equal to 4x. We know that its focus will be at 1 comma 0, and if you draw the line x equal to 1, it will be somewhere here, and suppose the next line x equal to 4 will be somewhere here. So this total area is required to be calculated, but since this graph is symmetrical about x-axis, if you calculate the top area a1, it will be same as this bottom area a2. So since a1 a2 are same, I can say that total required area a will be 2 times of a1. So to find out this a1, we can integrate from 1 to 4, because these lines are x is equal to 1 and x is equal to 4. So from 1 to 4, if we integrate y dx, we'll get the answer. So this is 2, 1 to 4. In place of y, I can write 2 root of x, because y square is equal to 4x dx. So this is 2 into 2, 4. X root x integration is x power 3 by 2, and again divided by 3 by 2. We can put the limits from 1 to 4. So till then, here we will be getting 8 by 3 and 4 power 3 by 2 minus 1 power 3 by 2. So we'll be getting the answer as 8 by 3. 4 power 3 by 2 is basically 8. 8 minus 1 will get 7. So this is 56 by 3, which is option number D. Question number 55 is the equation of the curve passing through the origin, given that the slope of tangent to the curve at any point is equal to the sum of coordinates of the point. So according to the question, the slope of tangent at any point is dy by dx, and that is given as the sum of the coordinates, so it is x plus y. Now this model is pretty much relatable with the standard linear differential equation dy by dx plus py is equal to q, where this p and q are either constants or function of the independent variable x. And to solve this type of questions, we find something called integration factor or integrating factor, which is e power integration of p dx. And once that is found out, we find the solution by writing y into integration factor is equal to integration of q into integration factor dx. So let us apply this concept in this particular question. So if you change this slightly and write dy by dx minus y is equal to x, you will realize after comparing with this standard format that the p value is minus 1 and q value is x. So our integration factor will be e power integration of minus 1 dx, which is e power minus x basically. And now we can write this as y into e power minus x is equal to integration of q, which is x, and integration factor, which is e power minus x dx. Now here we have to apply integration by parts. So we will take x as the first and e power minus x as the second function. And how do we apply that? We will write first into integration second. So that is x e power minus x divided by minus 1. So basically a minus will come here. Then we have minus integration of d by dx of first function, which is 1 only, into integration of the second, which is again minus of e power minus x. So this will become plus e power minus x dx. So we will get y e power minus x is equal to minus x e power minus x, and again we will be getting minus of e power minus x plus some constant. Since they said that the curve is passing through origin at x is equal to 0, we must get y is equal to 0. So left side it is 0, right side it will be 0 minus e power 0, which is 1, plus c. Therefore c value we are getting as 1. So finally we are getting the solution as y e power minus x is equal to minus x e power minus x minus e power minus x and plus 1. Divide by e power minus x, we will be getting y is equal to minus x minus 1 plus e power x. So this is observed in option number D. Question number 56 is, if y is equal to pi by 4 at x is equal to 1, then solution of 1 plus x square secant square y dy plus 2x tan y dx is equal to 0 is. So this question is from variable separation method. If we can observe that 1 plus x square secant square y dy can be written as minus 2x tan y dx, and if we start uh, separating the variables, basically we'll be getting secant square y dy divided by tan y, and on right side we'll be getting minus of 2x divided by 1 plus x square dx. So on left side we have all the variables of y, right side we are having the variable x. So let us integrate both sides. If we observe left side, if we put tan y is equal to t, then its differentiation is already in the numerator. So we can directly say that this is log of tan y. Okay, this is log of tan y, and that is equal to, again if we observe right side also, we are having 1 plus x square in the denominator whose differentiation is 2x. So again I can say that this is log of 1 plus x square, plus since all the terms are of log, I can say my constant also as log c, and therefore this becomes log of tan y plus log of 1 plus x square is equal to log c. And so after applying log m plus log n, this will become tan y into 1 plus x square equal to log of constant c. So therefore I can say tan y into 1 plus x square is equal to constant c. Now they gave the condition that at x is equal to 1, y is pi by 4. So here we will have tan pi by 4, 1 plus 1 square is equal to c. So tan pi by 4 is 1 and this will become 2. So constant c we have calculated 2. So this final equation will be tan y 1 plus x square is equal to 2. That will be our answer, which is option number B. Question number 57 is the differential equation of family of curves x log y is equal to c, where c is an arbitrary constant is. So we just need to differentiate this given equation of family of curves with respect to x. So first the integration of x will be 1. At that time log y will be constant. Next, if I keep x as constant, differentiation of log y will be 1 by y and then dy by dx, and that is equal to 0. So if you observe, after multiplying with y both sides, we will be getting y log y plus x dy by dx, that is equal to 0. It's already there in option number B, and this is free from arbitrary constant also. Differential equation must be free from arbitrary constant, and it is free from arbitrary constant. So therefore this is our answer, option number. Question number 58 is, which of the following is correct? So if we observe, you just need to understand one thing, that definite integration gives you the algebraic sum of areas from whatever limits are defined. Suppose there is a curve like this, okay, and you are targeting to find out the area from A to B. This is A, this is B. So this area is positive and this area will be negative, and the definite integration will count this as positive and negative only. So let's suppose if this was 5 and this was minus 7, so the net answer of A to B fx will be minus 2 only, because this gives the algebraic sum only. But if you take the modulus of the function, then what will happen? This minus 7 whatever is coming down, that will go up above x-axis. In that case the net area will be 5 plus 7, and that will give you 12 as the answer. But in case if you are taking the modulus of the integration itself, a to b fx dx, then your answer is 2. So definitely the highest answer is given when you are taking the modulus of the function and then integrating, because just taking the modulus of the function ensures that the graph of entire function is above x-axis, and then whatever areas are there, they will be having positive sign and will be getting a larger number. or larger value. But in case you are just integrating from a to b as it is, then there can be area above x-axis, area below x-axis, and then integration will give you the algebraic sum. So based on these, B is correct. Question number 59 is, if area under the curve bounded by x-axis y is equal to ex. Question number 59 is, if area under the curve bounded by x-axis y is equal to e power x, y is equal to e power x square, and y is equal to e power x to the power 4 between x equal to 0 and x is equal to 1 are a1, a2, a3, then. So we need to understand one thing, that since x belongs to 0 to 1 only, in 0 to 1, as you increase the power on x, what happens? The number will get much more smaller. So x square will not be greater than x, because although we feel that squaring will give us a bigger number, but here x is from 0 to 1. So in that case, it is opposite actually. Here also x square will be greater than x power 4. So if this is the case, if we take the powers on e, then also this will be applicable. From 0 to 1 has to be performed, and if we do that, we will be getting 0 to 1 e power x dx greater than 0 to 1 e power x square dx greater than 0 to 1 e power x power 4 dx. And this was representing your area A1, this one was representing area A2, and this one is representing area A3. So option number B will be correct. Question number 60 is, we are having a summation and we are having a limit n tending to infinite. So if you observe the pattern here, limit n tending to infinite, we are having every term numerator as n only, and the denominator's first term, every term is n square only. So denominator second term is changing, 1 square, then next time it is 2 square, and so on. Suddenly last, if you observe, it is 1 by 5n. So since everywhere numerator first term or basically the numerator term was n, I can say that last term also numerator should be n. So I can write numerator n, then denominator will become 5n square. And therefore we need to understand that what is this denominator at the last, because everywhere we are having the first term of denominator as n square. So definitely here also first term would have been n square. Then what about the second term? Definitely it must be 4n square. And since we were writing all the second terms of the denominator in form of squares, I can also say that this 4n square can be written as 2n whole square. It means we have understood the pattern, and I can simply write this as limit n tending to infinite summation r is equal to 1 to 2n, and this is given by n by n square plus r square. Now I can take n square common from the denominator, it will become 1 plus r by n whole square, and from the numerator one n will get cancelled. Since we have taken n square common in the denominator, only one n will be remaining. And this is the summation applied from r is equal to 1 to 2n, and don't forget the limit, it is tending towards infinite. So this is the situation right now. So this can be converted into a definite integration problem now, where we can say that r is equal to 1 to 2n, and we are having dr divided by n, 1 plus r by n whole square. Think about the substitution. If I put r by n is equal to x, when r is equal to 1, x will be tending to 0 as n is tending towards infinite, and when r is equal to 2n, in that particular case x value will become 2 because n will get cancelled. So I can convert this entire thing using r by n equal to x, and therefore I can also use dr by n is equal to dx. So variables will change, converted into 0 to 2, this dr by n we can write dx divided by 1 plus x square, and this is nothing but tan inverse of x. Integration of 1 by 1 plus x square is tan inverse x. Limits are 0 to 2, so I can put the limits. It will become tan inverse 2 minus tan inverse 0. Tan inverse 0 is 0, so left out answer will be tan inverse 2, which is option number B. Question number 61, the value of integral 0 to pi by 2 log 4 plus 3 sin x divided by 4 plus 3 cos x dx So to solve this question, we have to apply this property 0 to a function fx dx can be written as 0 to a function a minus x dx. So let us take the given integral as I and apply this property in that. So I can write I is equal to 0 to pi by 2 log 4 plus 3 sine 0 plus pi by 2 is pi by 2 only. So I can say this is pi by 2 minus x, and denominator will become 4 plus 3 cos pi by 2 minus x. Okay, so this is dx here. Now this becomes 0 to pi by 2 log 4 plus 3 cos x divided by 4 plus 3 sin x. Now if I consider the given question as equation number 1 and this expression as equation number 2, and if I add both this, I will be getting 2i is equal to 0 to pi by 2 log 4 plus 3 sin x divided by 4 plus 3 cos x, and plus, since the limits are same 0 to pi by 2, here itself I can write log of 4 plus 3 cos x divided by 4 plus 3 sin x dx. And we know that log m plus log n is log m into n. So I can write 0 to pi by 2 log. If you observe these two brackets, if we multiply, the terms will get cancelled and we can simply say it is log 1 dx. And log 1 is 0, and therefore the entire answer is coming out to be 0 for 2i, and therefore integral I, that is also 0. Correct option is C. Question number 62 is the value of the integral minus 1 to 1 log x plus root over x square plus 1 dx is. So this question is also a very simple property based question. If you are having an odd function fx, then integration from minus a to a for that function is basically 0. So for odd function, we know that property is f of minus x is equal to minus of fx, or we can also say that f of x plus f of minus x will be equal to 0. So let us apply and check here. If function is log x plus root over x square plus 1, then what will be the value of f of minus x? It minus x plus root over x square plus 1. If you observe, this entire thing will become log of x square plus 1 minus x square. So x square minus x square will get cancelled and we will get 0, which basically satisfies the criteria for odd function, for fx to be odd function. Okay, and therefore answer is a equal to 0. Question number 63 is the population of a city increases at a rate proportional to population at that time. If population of city increase from 20 lakh to 40 lakh in 30 years, then after another 15 years the population is. So as per the question, dp by dt, this is the rate of change of population. It is proportional to population at that time. Let's suppose population is p, so it is proportional to p. To remove this proportionality constant, I need to write dp by dt is equal to some constant k times p. Now I can say dp is equal to k dt, and p basically I brought left side, and now if I integrate both side, I will be getting log p is equal to kt plus c. So we are having two things to find out now. One is k, one is c, and for that only we are having data also in the question. So if you observe, if the population of city increase from 20 lakh to 40 lakh in 30 years, what does that mean? Initially it was 20 lakh. So at t equal to 0, I can say p was 20. So this was, although lakhs are there, at t equal to 0, p is equal to 20 lakhs. So I can say log 20 is equal to k into 0. So first term is gone. We are having c equal to log 20. Now this expression I can write, therefore log p is equal to kt plus c ke jagah pe we can write log 20. Now since the population of city increased to 40, now this is log 40 in 30 years. So I can say this is 30k plus log 20. Therefore, I can say 30k is equal to log 40 minus log 20, which is basically log 40 by 20, because log m minus log n is log m by n, and therefore this is log 2. So k value also we have calculated as 1 by 30 log 2. Now they are asking after another 15 years the population will be. So this word is important. After another 15 years means what? Already 30 years over, and after another 15 years means t is equal to at t is equal to 45 years they are asking. So we can apply the given equation log p is equal to this expression. Again we can apply kt. So k is 1 by 30 log 2 and time given is 45 and plus log 20. So this comes out to be 3 and here we have 2. So we are having 3 by 2 log 2. Okay. So this will become log 2 power 3 by 2 into 20. Again using the property log m plus log n is equal to log m into n. So we are having log p is equal to log 2 power 3 by 2 into 20, which basically means population at that time will be 2 power 3 by 2 means root 2 power 3, which is 2 root 2. So this will become 40 root 2. So 40 root 2 lakhs is the population. Option number B is right. Question number 64, we have the integral dx divided by cos x root over cos 2x. In place of cos 2x, I can write cos square x minus sin square x. Okay. And now let us divide inside this square root itself by cos square. So this will become 1 and this will become minus tan square x. So since we have divided by cos square inside the square root, I should have written here cos square x in place of cos x, correct? So this becomes cos square x root of 1 minus tan square x. This in turn becomes secant square x dx divided by root over 1 minus tan square x. So best possible substitution in this particular case is tan x is equal to t. Therefore I can say secant square x dx after differentiation, this is becoming dt. So in numerator I can say it is dt, in denominator I can say it is root over 1 minus t square. And what is this formula basically? This is sine inverse of t plus some constant c, which basically means this is sine inverse of t means tan x only. So correct option is option number A. Question number 65 is dy by dx plus 2 tan x into y is equal to 2 sin x. The y value at pi by 3 is given to be 0 and they are asking y at pi by 4. So again this dy by dx plus 2 tan x into y equal to 2 sin x. This is linear differential equation of the model dy by dx plus py is equal to q. So we can calculate the integration factor as e power integration of p dx. So if you observe in place of p, we have 2 tan x. This will be e power 2 integration of tan x dx. And what is integration of tan x is log sec x. So this will become e power log secant square x. And since the base of log is also e, we can write simply secant square x. This is the integration factor. Now the solution is given by y into integration factor, which is y into secant square x, that is equal to integration of q into integration factor. So q is 2 sin x and integration factor is secant square x dx plus some constant c. So this is y secant square x, that is equal to, I can write this as 2 secant square x. If we bring in the denominator, it will become cos square x. So I can write one as cos x, another cos as separately. So sin by cos will be having tan and cos will go in the numerator, it will become secant. So secant x tan x is the thing that is remaining overall. So the integration of this is basically secant x only. So we are left with y secant square x is equal to 2 secant x plus constant c. Now we just need to find out the constant c by using the data given y pi by 3 equal to 0. So at x is equal to pi by 3, which is basically 60 degree, secant value will be 2. So secant square pi by 3 is basically 4. So I can write this as, and y value is 0. So at x equal to pi by 3 we are having y is equal to 0 also. So left side will become 0 is equal to 2 times of secant x is basically secant pi by 3, which is also 2, plus constant c. So c value we are getting as minus 4. So our answer will be y sec square x is equal to 2 secant x minus 4. And now if I put pi by 4 in place of x, I will be getting the answer. So y secant square pi by 4 is equal to 2 sec pi by 4 minus 4. So sec 45 is root 2. So if we square, we'll get 2y, that is equal to, again this is 2 root 2 minus 4. So 2y is equal to 2 root 2 minus 4. So what is the value of y? It will be root 2 minus 2, which is option number C. Question number 66 is, let function is satisfying fx plus f pi minus x equal to pi square, then integral 0 to pi fx sin x dx is equal to. So let us suppose we have this given integral 0 to pi fx dx, fx sin x dx basically, and this is equation number 1. So we can apply the property in this question that same integral I can write lower limit plus upper limit minus x in place of x. So that will become pi minus x, and this will also become sin pi minus x dx. This is our equation number 2, which basically will transform to 0 to pi f pi minus x, and sin pi minus x is also sin x only. So this is our second equation. So if we observe, on adding 1 and 2, we are going to get 2i is equal to, sin x will be the common term, limits are already same 0 to pi, so we'll be left out with fx plus f pi minus x times sin x. And in place of this functional relation, I can use pi square. So that will be 0 to pi square sin x dx. Pi square is a constant, so I can take it outside, and basically it will be sin x integration, that is minus cos x, and if I put the limit 0 to pi, cos pi is minus 1, so this will become pi square 1, and then minus of minus 1, that is basically plus 1, so 2 pi square. But this is the answer of 2i. So I is equal to pi square, which is option number C. 67, we have integral of dx divided by x plus 1 to the power 3 by 4 into x minus 2 power 5 by 4. Same integral we can express like this: dx by x plus 1 divided by x minus 2 to the power 3 by 4. But since we have written x minus 2 in the denominator of x plus 1, we have to balance that thing, and for that I need to multiply with x minus 2 power 3 by 4. Already x minus 2 power 5 by 4 is in the question, so 5 by 4 and 3 by 4 will add up and give 2. So I can write x minus 2 whole square. Now if you carefully observe, in the differentiation of x plus 1 by x minus 2, we get x minus 2 whole square. Denominator square is there. That means if I take this term as t and start differentiating, numerator differentiation will be 1 into denominator as it is, then minus numerator as it is and denominator differentiation 1 divided by denominator square x minus 2 whole square dx equal to dt. So from here on the top, if you observe in the numerator part, x will get cancelled, we'll be left with minus 3. So I can write dx divided by x minus 2 whole square is equal to minus 1 by 3 dt. So now using this, the entire integral expression will change to this dx by x minus 2 whole square. I can write dt divided by minus 1 by 3, that will go outside, that divided by t power 3 by 4. It means the answer will be minus 1 by 3 t power minus 3 by 4 integration dt, and that will be given by minus 1 by 3 t power minus 3 by 4 plus 1. If we do, we will be getting 1 by 4, and same 1 by 4 will be in the division also. So that will give us minus 4 by 3 t power 1 by 4 plus constant c. So you can observe it is option number D. Basically you just need to put t value at the end, that is x plus 1 by x minus 2. Question number 68 is, Integration of cos x minus sin x by root over 8 minus sin 2x dx can be given as A sin inverse sin x plus cos x by B plus C. Then the ordered pair AB is. So if you observe this question carefully, we have cos x minus sin x in the numerator. So using the sin 2x that is in the denominator, if you can bring or you can modify or manipulate sin 2x in such a way that if you can bring sin x plus cos x term in the denominator, then we can put sin x plus cos x is equal to t, whose differentiation will be there in the numerator, that is cos x minus sin x dx equal to dt. That is the thought process. So I can write minus sin 2x, I can write as sin x plus cos x whole square. That will give me actually 1 plus sin 2x. Okay, so I cannot write sin 2x like this, sin x plus cos x whole square, but if I open this, I will get sin square x plus cos square x, that is 1, and I will also get 2 sin x cos x, which is basically sin 2x. So that extra one which I am getting, to handle that or to balance that, I will make this 8 as 9, so that when I open this bracket, I will be getting 9 minus 1 plus 2 sin x cos x. So 9 minus 1, I will get 8, and this 2 sin x cos x, that will give me sin 2x. That's all. So this is a simple manipulation that we need to understand. After that, once this substitution is done, the integration is basically dt by root over 9 minus t square, whose answer is given by sin inverse t by 3, which is basically I can write as 1 into sin inverse. T value was sin x plus cos x divided by 3 plus some constant c. Here also we can add some constant c. So if we compare with the answer, then in place of A we have 1 and in place of B we have 3. So the correct ordered pair is 1 comma 3, which is option number A. Question number 69 is to find the general solution of the differential equation. So we can write the given differential equation as dy by dx, that is equal to y by x plus root over that x I will send inside the root, so it will become x square, so it will be 1 minus y by x whole square. Now we can put y by x is equal to v, or which also means that y is equal to vx, and if we differentiate with respect to x, I will get dy by dx is equal to v plus x dv by dx. So let us use this substitution here in this question. So we'll be getting v plus x dv by dx, that is equal to, again y by x is v plus root over 1 minus v square. If you observe, v will get cancelled, and after that we can apply the normal variable separation method. So dv by root over 1 minus v square is equal to dx by x, and if you integrate both sides, we'll be getting sin inverse v is equal to log x plus some constant c, and that is nothing but sin inverse y by x is equal to log x plus c, which is option number D. So D is the correct answer. Question number 70 is integration factor of the differential equation dy by dx plus y is equal to 1 plus y by x. So if we have a differential equation of this model, dy by dx plus py is equal to q, where p and q are either constants or they are functions of x. Okay, I will repeat, p and q are either constants or functions of x in this model. Then you can write the integration factor as e power integration p dx. So if you observe this question carefully, I can write this as dy by dx plus y is equal to 1 by x plus y by x to the left, and I can take y as common, so I will be left with 1 minus 1 by x, that is equal to 1 by x. Now whichever term is there with y, that is our p basically. So this is the p, so I will apply the integration formula 1 minus 1 by x dx on e. So this is e power integration of 1 is basically x, and 1 by x integration is log x, and then I can separate this, it will become e power x into e power minus log x. Further I can do the separation, so it will be e power, this minus 1 I can Now this is e power x into e power log x becomes log x power minus 1. Now since this is log base e only, this term will vanish. Only thing left will be e power x into x power minus 1, which is e power x by x, which is option number D. Question number 71 says let fx is equal to x minus box of x for every real number x, where question number 71 is let fx is equal to x minus greatest integer x, then minus 1 to 1 integration fx dx is basically this x minus greatest integer x is, or the integral part of x, this is basically the fractional part of x. And if you see the graph of fractional part of x, it simply goes like this. It reaches 1, then again it goes like that, again at 2, 2 to 3, again it goes like this. So always it repeats, and every time you can see there is a formation of triangle. So if this is 1, this is also 1, right? Because this is at 45 degree and this is 90, this is 45. So if this is 1, then height will also be 1. And since we know the sides of this triangle, we can say the area of one triangle is 1 by 2 base into height, which is 1 into 1. So every triangle will contribute 1 by 2 square units. The integration is from minus 1 to 1. So I know that minus 1 to 1, if I break, I will be getting two different triangles, minus 1 to 0 fx dx, and then one I will get from 0 to 1. So if we add both the areas, we'll be getting 1 by 2 plus 1 by 2 only, which is 1. So answer is 1. Question number 72 is order of the differential equation whose general solution is given by y is equal to c1 e power 2x plus c2 plus c3 e power x plus c4 sin x plus c5 is. So I will write the given equation one more time. C1 e power 2x plus c2 plus c3 e power x plus c4 sin x plus c5. Now if we simply count the constants, we may feel that c1, c2, c3, c4, 5 arbitrary constants are there. So order will be 5. But we can do the separation here. We can write this as c1 e power c2 and then e power 2x I can write separately. Now this is not two different constant. We can combine and say that it is some constant a. So it is basically a e to the power 2x. And then whatever is there, we cannot remove. We cannot erase c3 simply. So every other constant is basically independent. We cannot remove any other arbitrary constant from here. So if we count now, we have 1, 2, 3 and 4 arbitrary constants which are basically independent, and therefore the order of the differential equation will be 4. Order will be equal to number of arbitrary constant or number of independent arbitrary constant, which is 4. Question number 73 is integration a to b fx by fx plus f a plus b minus x dx is equal to 10, then possible value of b minus a is. Now this is a very simple property based question. If there is integration from a to b fx by fx plus upper limit plus lower limit minus x dx, then that value is given by upper limit minus lower limit by 2, and that value is directly given to us as 10. It means the difference between upper limit and lower limit b minus a is nothing but 20. So this was pretty simple question. Question number 74, the difference between degree and order of a differential equation that represents the family of curves given by y square is equal to a into x plus root over a by 2. So to solve this question, let us first of all differentiate with respect to x. So we'll get 2y dy by dx, and then that is equal to a, x differentiation is 1 and root over a by 2 differentiation will be 0. So we are left with only a. So we'll use this a value in the given equation in order to make the differential equation. So y square is equal to, we have 2y dy by dx in place of a, and then we have x plus root over, we have again in place of a 2y dy by dx divided by 2. Now we can write y square is equal to 2xy dy by dx I am writing as y dash plus this 2 and this outside 2 will get cancelled once they multiply. So we will be having y dash square root of 2y dash. I can take one y common, and this will be y minus 2x y dash on left hand side, and then y dash root over 2y dash on right side. We can remove this extra y on both sides and therefore square on both sides. So y minus 2x y dash whole square is equal to get y dash square after squaring, and then 2y dash, which is basically 2y dash cube. The highest order derivative is 1, which means order is 1, and the highest power on the first order derivative is 3, so degree is 3. So the difference between degree and order is 2. So right answer is 2 for this question. Question number 75 is 8 by pi integral 0 to pi by 2 cos x power 2023 divided by sin x power 2023 plus cos x to the power 2023 dx is. So let us suppose this integral I is 0 to pi by 2, and we have cos x to the power 2023 divided by sin x power 2023 plus cos x to the power 2023. Right, now we have a property that 0 to a fx dx integral can be written as 0 to a f of a minus x dx. Using this property here means that in place of x we will be writing a minus x, means pi by 2 minus x. Therefore cos x will become cos pi by 2 minus x, and sin x will become sin pi by 2 minus x, which means cos will change to sin and sin will change to cos. So same integral I can write as 0 to pi by 2 sin x to the power 2023 and divided by cos x to the power 2023 plus sin x power 2023. Now if you observe, denominator is still the same in first and second both, but numerators are different. So on adding, since denominator is same, numerators will get added up, and then numerator and denominator both will become same, and we can cancel all the terms. It will become sin x power 2023 plus cos x power 2023 and divided by same term because denominator was same already. So sin x power 2023 plus cos x to the power 2023, and once these terms get cancelled, we are left with integration of 0 to pi by 2 1 dx, which means this is equal to pi by 2, and the integral answer is I is equal to pi by 4, but they asked 8 by pi times of the integration answer. So that is 8 by pi into pi by 4. Pi and pi will get cancelled. 8 by 4 is 2. So 2 is the right answer for this question.